Miss.
Assalamu alaikum, Akifa. Hi, Sharon. Just 1 minute. I remove these files and then we'll start. Okay. But I actually haven't opened any classroom or class folders for you. 8 to October, 8 to Maths, May 25. This is actually May 25 and Jan 25 next because we're going to plan to sit for 1 unit or 2 units of maths in Jan and then rest of the units in May 25. Okay. So basically, this is the plan. For your maths E2, we're going to have what? P3, P4, these are like compulsory units for pure maths. And on optional units, you guys have available units of S1, M1, and D1. Right. Now, I think for Abir, she's choosing M1. For Hamza, he's choosing S1, and Sharon is choosing D1. Right. For Akifa, which one are you going to take for your E2?
I'm taking S1.
S1. Okay, so you and Amir are going to be under the same batch for S1. Okay, Amir is going to be on a separate class, and Sharon is going to be on a separate class. But for P3, P4, we're going to have similar classes. Now, this M1, S1, and decision maths, these are not entirely that much big topic. For all these three optional units, they're going to have like 6 chapters on maximum. And top of that, on the 6 chapters, I mean, for S1, actually, they have 7 chapters. But we do not actually do chapter 1 for S1. For S1, M1, D1, we do not do chapter 1 because they're quite elementary level. For T1, I would provide some worksheet to actually work on the basics, but other than that, we're not going to follow the book for the chapter 1. For M1 S1, we're completely going to ignore chapter 1. Okay, for M1 actually, they have few statements like what is rigid particle, uh, what are this? How do you consider an object as a wave, as a particle? Why would two objects connected to a string will travel in the same acceleration? All these basic concepts about physics. So what I will do is that I will take an theoretical class for chapter 1 only, and I'll explain that what does every term means: inextensible, rigid, light. Right? These are the terms that you have to explain in your answers. In chapter 1 in M1 is entirely theoretical. Nothing maths type of working would be coming out from your M1. But for S1 chapter 1, that is entirely a waste of time. Okay, for S1 chapter 1 is there's nothing there. I mean, they would only ask you what is discrete variable, what is random variable. I can explain that in solving the questions from your chapter 2 also. So for S1 chapter 1, for M1 chapter 1, for D1 chapter 1, we're not going to follow the book. But other than that, all the rest of the chapters will be followed from your book, and a few worksheets will be provided in cases for tough chapters. For example, in M1, the questions from chapter 4, 5, 7, and 3. 4, 5, 7 is basically considered as connected particles, and 3 is vectors. For M1, I'm talking about. So, for those cases, we have to provide you extra worksheets because those are like tricky concepts to understand. So I think for those 3 chapters, for those 2 chapters actually, 4, 5, 7, and I consider that as one chapter. I'm talking about M1, 4, 5, 7. These three actually, I do these 3 sections or 3 chapters in one under one chapter of connected particles. So this chapter and 3 vectors. For these 2 chapters, we are going to provide you worksheets. For S1 again, um, I think for chapter 4, probability, and for normal distribution. Normal distribution was maybe 7, if I'm not wrong. Yeah, 7. So for 4 and 7, we are supposed to do the extra worksheet classes. And for D1 also, we're going to do few extra classes. D1 is not that much extremely different. D1 is quite like kind of related to FP1, so I don't think that would be difficult for Sharon as you had FP1 in the AS. And these are for the optional units. Okay, for your compulsory units P3, P4, we're going to follow the entire book from chapter 1 to the last chapter. For I think P1 you have 8 chapters, and for P4 also you have 8 chapters. Right, for P4 also you have 8 chapters. So basically you have to finish this 16 chapters. But our main motive would actually be solving this unit before Jan 25. Right. And I would also try to finish S1, M1, and D1 before Jan 25. We can easily complete M1. But for S1, it's a little bit lengthy because 4 and 7, these two chapters are quite long. Right. But saying how many months do we have? June, July, August, June, July, August, December. 7 months. And I'm going to not consider December as a month because that will be kind of wasted for taking box and solving question paper. So after December, we only have like 6 months, right? No, we can solve S1 and M1 within this time. 6 months is a long duration of time, no problem. Okay, so in that case, we're going to, I mean, for this batch, basically P3, M1, S1, or D1 can be considered to be under the Jan 25 batch, and only P4 will be doing in our May 25. Okay. But then again, it depends on how many units do you have for Jan 25 session. For example, if you are sitting for maybe only 3 units, maybe or only 4 units, then I would consider take that S1 and M1 with the 4 units. Okay, because sitting for 5 units is not that much difficult. But if you're considering taking like entire A2 of other subjects in Jan, in that situation, I would suggest that since we already are going to create one session for May 25, right? In that case, we will actually move you to the May 25 session for S1, M1, and D1 also. So it depends exactly that how many units you're going to like register for the Jan 25 session. But so far, the planning is this that for P3, M1, S1, or D1, we're going to finish that before Jan 25, and we're going to hold P3, P4 for your May 25. But then again, actually, P3 is not that much lengthy. I mean, if you consider the first 3 chapters, chapter 1, chapter 2, chapter 3, we can actually finish the entire chapter 1 in today's class. And chapter 2 is also not that much difficult. It's an extended version of little bit of functions. And chapter 3 is also not that much difficult. Only one part of chapter 3 is difficult, that is 3E, where they are talking about arc sine, arc tan, arc con, arc cos. That is basically the inverse of tan, sine, cos. Nothing that much extremely difficult, but I would say that 3E for P3 is extremely new to us. Okay, other than that, integration is a little bit lengthy, not difficult, but lengthy. It takes a lot of time to solve. So it obviously takes a lot of practice to solve those kind of lengthy questions in your exam paper. So on P3, I would suggest that you have only like what 2 chapters difficult. Okay, that is your different that is your integration and that 3E part. Other than that, all the other chapters are not that much difficult for P3. And for P4 also, the integration is quite difficult. I think for P4, the chapter is 6 and 8 integration part. Okay. So what our planning is now, we're going to complete P3. We are starting in June, right? June, July, August. Yeah, we're going to complete like 80% of P3 in June, July, August, and in September, like from September, we are going to increase, no, not from September, from October, we're going to increase our classes to pure maths classes to 3 days. Now we're going to have what, 2 days of P3 classes. By the way, I'm sorry, I didn't say the time yet, but okay, as I was saying that for P3 classes, our classes are going to be like 2 weeks before October, and from October for pure maths, we're going to have 3 classes. Okay. So now on, for the time being, our classes are going to be on Friday and Saturday. Oh, wait, not Sunday and 1 minute. I think it was on Thursday, right? Sunday and Thursday. Sunday and Thursday. I'm only giving you the time according to Bangladesh time because all of you have different time zones. According to Bangladesh time, Sunday at 2 p.m. and Thursday at 4 p.m. So I think, oh no, not Saturday, not Thursday at 4 p.m. Wait, maybe I'm making some mistake. 1 minute. Let's get this book. Yeah, actually Thursday at 4 p.m. But I think for Abir and Sharon, you guys are going to have problem at Thursday at 4 p.m., right? Because that would be on like 1 p.m. for your timing.
For now it's okay. Like until August, it's okay.
Okay, then we'll actually continue with this. After August, maybe we can shift the class timing a little bit earlier. Okay. This is the timing for P3, and this is actually going to remain as this as it is for the entire month, for the entire course. Okay. From October, we're going to start. This is from what June to October. So not October, September actually. And then again from October onwards, we're going to have another class. Mostly, I will take that class on Saturday. Okay. I'm not going to give you an exact time for that P4 class. We're going to start from October, but that will start from Saturday, 12 p.m. or maybe 1 p.m. Okay. So approximately 12 p.m. This is from October. October, this will continue to till your May 2025 sessions. Okay. And from September, actually, from September onwards, as I'm actually planning that we'll be starting from June, July, August, September, we can finish up to chapter 6. So that means on September. So from September onwards, we're still having two classes. We can solve what, 7 and 8. 8 is not actually considered as a chapter. In P3, chapter 8 will actually take you like one entire class to complete chapter 8, P3. So I'm not considering chapter 8 as a chapter over there. So for chapter 7, that will only be left. So in October, we are going to do the classes in this way that we are going to first finish our chapter 7 during the first week of October. And from the second week October onward, we're going to start our question papers. So for October and November, if we continue with our question papers, our mocks will start that on December. Okay. Or we can actually take one mock in October also. For January session, I think the registration ends at October, right? Yeah, the registration starts mid-September and ends in maybe like last week of October or something. So before our registration, I would actually take one more for these units so that I can actually suggest that if you should actually register for the units or not. Because at the end of the day, you are again anyway going to make a session for May 25 also, right? So if your mock results are not that much quite good, I would suggest maybe move on to May 2025 session. So that is a later part. Before that, this is the planning so far. From June to September, we're going to finish the syllabus. From October onwards, we're going to finish our question papers for P3 and we'll start P4. And yeah, and then again for P4 also, we'll hopefully complete P4 by the end of February. Okay, so if we can complete the P4 by the end of February, in that case, again we can start our question papers from March and we'll solve our mocks or other presentations during April. And then similar concept, like similar process will be done for S1 also. For S1, we're going to complete the syllabus. I think for M1, we can easily complete the syllabus, M1 and D1. We can easily complete the syllabus by the end of August. Okay, but for S1, that is a little bit lengthy. So I would actually need like mid October or the entire October to actually complete the total syllabus for S1. And from November onwards, you can start solving the question paper for S1. For M1 and D1, they're not that much lengthy. We can complete the entire syllabus by October. Sorry, by the end of August. Okay, so for M1 and S1, we have a lot of time for solving question papers, doing mocks and everything. But for S1, it will be a little bit lengthy. Okay, other than that, I'll write down the class times over here, the final class times, so that you guys can use it and let me know after if you continue with the classes. So, for example, P3 will remain the same. I'll just remove all this. So far, we're only starting P3. We'll start P4 from October onwards. So the classes will be on Sunday and Thursday. If I am going to write this in terms of Abir and Sharon's time zone, in that case, this is going to be 11 a.m. and 1 p.m. And I think Akifa and Ami, you guys are from Saudi. So in your timing also, it's the same time zone, right? Yeah, they have the 3 hour time difference. Yeah, so this is the same timing for shortly also. This is for P3 classes and for S1. S1 is at 8 p.m. That is going to be like 5 p.m. for both of you, Akifa and Amin. So 5 p.m. M1. M1 is on 11 a.m. again. This is on Wednesday, by the way. So this is no S1 is 5 p.m. M1 is 11 a.m. on Wednesday, and decision one maths will be on Friday. Friday at 9 a.m. For the entire June month, I will actually consider taking one classes for M1, S1, and T1 per week, by the way. Okay. And from July onwards, we actually have to increase the class timings to 2 days a week. So most probably, we are going to have like classes on Saturday also for S1, M1, and T1. For T1, I think I will increase the class duration. For Friday, we're going to have a 2 hour class in one time. So if we start from 9, we'll end at 11 for Sharon. And for Abir, Atifa, and Amin, we're going to have to increase the class timing from Wednesday to Friday, Wednesday to Saturday. Is there any problem from these class timings?
Nope.
No,
No, it's all good.
just for now. I mean, after 2 months, our school is gonna start, so there's gonna be some difficulties at that time.
Mhm. In which class is clashing with your school's timing?
Um, I guess Thursday. It's just a 4 hour difference, right? So
3 hour
you know,
difference.
yeah,
No, this is
3 hours.
actually according to your time, by the way. This is not my time. This is according to your time.
Oh, okay, all right.
Okay, so
Still,
on
me
your time,
Sunday 11 a.m. I got school at that time. Then I mean, miss, we can change it. Later on, we can just continue for these 2 months, and at this time, it's okay for me.
okay. I think similar cases at this Thursday class would actually clash with Sharon and Nabil also. We would have to change it. So I'll actually consider about changing it by the first week of August. Okay. Most probably we'll change it to 7 p.m. of my time, which is going to be like, oh no, not 6, not 7 p.m. of my time. We would actually have to conduct that at late night then, most probably at 7:30 or which is going to be, yeah, 7:30 p.m. And we consider changing this Thursday timing to 7:30 p.m. Okay, now we will start with our chapter 1. Okay, chapter 1 in P3 is extremely easy. 1 minute. Well, we can entirely solve chapter 1 P3 in today's class. Okay, by the way, this is your content. Right. First one is about algebraic methods, and this is quite easy, but it also has some differences over there. So I will suggest do that chapter 1. Okay. And then again, chapter 2 is also easy. 3 is easy. This one is tough. Art style, art cost time. And then this one is extremely easy. We did this logs in our ASP2 also, in our IGCSE further maths also. So extremely similar to that. Nothing different over here. Trigonometric addition formula is not that much difficult, to be honest. This is entirely related to your chapter 4 of P1, if you remember, translation transformation. Also, one thing, translation transformation is the basic for your entire A-levels pure maths. Okay, I hope all of you remember chapter 4 of P1, right? Chapter 4 of P1, translation transformation. Now, this is the basic part. We are not going to explain translation transformation in A2, But what I will provide is that I'll actually take the recordings from my AS classes and give it to you so that you can revise that translation, transformation, stretching, and everything before we start with our P2, P3 classes. Translation, transformation is needed for P2, P3, P4. In all the four units, they're extremely important. Then again, this one is extremely easy, and this one is tough. Integration. Differentiation is also not that much tough. If you have, if you had IGCSE further pure maths, then it is not tough. We did chain rule, product rule, quotient rule, all of these things in our IGCSE further pure maths, right? So differentiation is nothing going to give you. Only integration is a little bit tough because now you have this reverse chain, integration by parts, and all these things. This is new to us, but not that much difficult. It's mainly lengthy, and you have to practice a lot from chapter 7 integration. Otherwise, it's not entirely like math science. It's extremely difficult, not that, but quite lengthy. Can you guys just wait 1 minute? I'm actually getting an important call. 1 minute. Hello. Okay, sorry, I have to go and receive a call because my sister is calling. Okay, now we are starting with chapter one today, right? I'm going to complete the entire chapter, so it will be a little bit lengthy. I promise from our next classes, the classes will not be that much lengthy. Okay? Only this class I'm going to extend a little bit lengthy. So for your chapters, by the way, mostly what happened in this, for example, chapter one, we have three sections, 1A, 1B, 1C. In our classes, I will actually explain the topics from your exercise, okay? 1A, 1B, 1C. And there is a chapter review after every section, after every chapter. That entire chapter review will be your homework. And you guys will have to complete that homework, make a PDF of your working and submit it in that classroom. Okay. By the way, one thing I forgot to introduce you guys with that we are going to have our classrooms, right? I actually archived all my old classrooms because today I was actually creating space in my classroom. 1 minute. I'll actually open one of my archived classrooms so that you guys can see exactly how our classrooms will be arranged. This is our old classrooms, by the way. Now, for example, this was your May 24 S1 classes, okay? And mostly what happens for the class recordings, I always share the class recordings with your email address. So, I mean, you'll get a notification in your email address that I shared the class recordings with your email. And also to find out the links, you can get the links in the classroom under this kind of files. So we are going to create sections for S1, chapter 2, chapter 3, 4, 5, 6, 7. And then again, using these links, you can find out from the screen, or you can go to classwork and find out the arrangement for every class. Chapter 2, if there's a worksheet, we're going to solve the worksheet, and then the recordings for the worksheet will be provided under this. Okay, for example, the video section over here indicates that the recordings for chapter 3 will be inside this videos folder. And what is class slides, by the way? Class slide is basically the slide on which I will do the maths. I'll solve the maths, and those solved maths will also be provided to you. Okay, these are the class slides, by the way. But basically, my S note files, whatever I'm going to write in this file is considered as the class slide. And that will be also added in your classroom. This is how, in generalized, all your classroom looks like. P3, S1, and P3, S1, P4, M1, D1, and all the spaces. I'll note this, and we're going to start with chapter 1A. This is basically what simple LCM, right? We're going to finish that. Oh, wait, this is 1B. 1 minute. Where is 1A? Oh, this is 1A. This is again simple LCM, and in 1B also you have simple LCM, improper fractions, okay? And in 1C again, you have like a little bit of long division involved with it, but not that much tricky. Okay, so let's start with 1B and 1C. We'll complete 1B and 1C quite quick. And also there will be classwork from 1A. So I hope all of you have access to your phone right now. So in classworks, you guys have to take a picture of your working and send it to me in my WhatsApp. As we still do not have a group yet, I would suggest send me the WhatsApp in my personal inbox. Okay, WhatsApp inbox. So let's start with 1A. Also for I'm not sure if I'm pronouncing your name correct or not. I think it's Nasser. Right. So Nasser, you didn't actually miss anything. You're going to start the conceptual classes from now. And still now we're actually considering about how I will complete the syllabus and everything. Okay. 1A, by the way. Sorry, I forgot to take a screenshot for the question. Mhm. This is A by B. I'll complete question 2 and 3. Okay. So this is going to be a classwork in that case. Question 3 is going to be a classwork for you guys. That's the later part. Let me finish question 2 and 4 first. Let's explain that. And after that, you guys are supposed to do question 3. Okay, now over here, they have provided you what? Three fractions, right? As you can see, this is fraction 1, this is fraction 2, this is fraction 3. Fraction 1 and 2 are multiplied, and fraction 2 and 3 are divided. And at the end of the day, you have to simplify all of these things and write it as a single fraction. Okay, here, if I explain this thing for the last time, for example, you have A divided by B, and this first fraction is divided with the second fraction, which is C by D. I can write this in this format: A by B divided by C by D. Whenever your denominator itself is in a divided format, for example, your denominator is in a divided format, right? We can see that. In those cases, your denominator will be inverted and gets multiplied with your numerator. So now your numerator was A by B, that was your entire numerator, and your denominator fraction will be inverted. Previously it was what? C by D, and now it will be inverted to that original version. So it will be D by C now. It is going to be D by C, and now this inverted fraction will be multiplied with your first fraction, first numerator. This is a concept we're going to use for solving question 2. Now I'm going to write it, like, put it over here. This is like a graph format. Okay, is there any problem from this format, by the way?
No, miss.
Okay, then we're going to start. For Nasser and Akifa, if you guys are facing any problem, please turn on your mic and let me know about it. So I'll just write this entire, there are what? There are quadratic equations in on both numerator and denominator for the three fractions, right? So you have 2x squared, 11x minus 40 divided by x squared minus 4x minus 32. I'm going to explain this maths with as much detail as I can, okay? Only for this maths. From the next maths, we're going to start using shortcuts. And then again, 6x squared minus 3x minus 45. Now, these two fractions will be now multiplied with that inversion of the third fraction because it was actually divided with them. Now, eventually, this is what they look like. F1 multiplied with F2 divided by F3. Right, since F3 was itself a fraction, so it will be inverted and gets multiplied with the numerator. So I'll just remove this. Now your 10x squared minus 45x plus 45, the denominator of the third fraction will go to the numerator and the numerator of the third fraction will go to the denominator. So 8x squared, 20x minus 48. Right. From this part, now I can understand, okay, they're all in multiplication format. It's easier for me. Now I'll start doing middle term for this part. Like for all the 6 polynomials they have provided you with, I will start doing quadratic factorization for them. In that case, we have 2x squared. Sorry, we have 2x squared, 11 and 40. Right. So 2 minus 11 minus 40. We're going to get x plus or x minus 8 for this part entirely. We're going to get 8 and 5 by 2. Also, one thing, we cannot skip middle term for this part, by the way. You have to show that splitting process, that you have split that 11, and then from that point, you can move on to your final factored format, but you have to show the splitting. For middle term, you cannot skip middle term for P3 also. For P4 only, for P4 integration, in some cases, they will allow you to skip middle term. They will allow you to skip factorization, but for other factors, you cannot skip factorization. You have to show all the steps, by the way. So for this case now, I'm going to split it as 2x squared. 18 becomes 16x, and that one becomes 5. So 5x minus 40. Okay. This one has to be positive. This is divided by x squared, 4 and 32. So 1 minus 4 minus 32. This one again turns out to be x squared, 8x, 4x, 32. And this is positive. And then again, this will be multiplied with your other fractions, 16 and 8. Is 1, 8, 16. So you have x minus 4. Okay, that is your only piece. So x squared, 4x, 4x plus 16. This will be again divided by for Dushan, you didn't miss anything. We have just started with 1883, so you can just continue watching this. Okay, nothing you missed so far. This is 6 minus 3 minus 45. I'm trying to factorize all the 6 polynomials you can see on the screen. So this is going to be again 6x squared. 6 into 3 is what? 18. It's going to be 15. 15x minus 45. Okay. And this line, I cannot fit that third fraction, so I would actually have to write the third fraction in the second line. Okay. But that is because I cannot fit them. So okay, let's just write this over here. So I can fit the 3 fractions on the same screen, on the same line. Now for the third fraction again, you had what? 10 square, 45 and 45, right? So 10 minus 45 and then plus 45, which is 30 and 15. So 10x squared, 30x and 15x plus 45. This will be divided by 8, 20 and minus 48. That's again 3 over 2, which is going to be 12 and 32. So 8x squared, 12x, 32x minus 48. This is going to be positive. This has to be positive, right? Okay, now the splitting process is done. We'll now factorize them. For example, from the first fraction, for the first pair, 2 and 8, 16, I can take 2x common. So I'm going to get 2x, x plus 8. And then again plus 5 is going to be x plus, minus 8 divided by, again from this part, since I do not have any number common, I can take one alphabet common, right? Always remember, when you have x square and x, you're going to take the smallest power as common. So x will be taken as common and x minus 8. And then again for the next part, 4 common, so x minus 8. This will be again multiplied with x common, x plus 4 common, x plus 4 divided by, from 6x squared and 18, I can take 6x common, 6x, x minus 3, 15 into 3 gives me 45. So I can take 15 common, and that will be again x minus 3. Multiplied with the last fraction from the numerator at start, taking x 10x common, so we have x minus 3 minus 15, again x minus 3. Divided by, lastly, 8x squared and 12, right? So I can take what? Wait, 8x squared and 12, I can take 4 common, right? Always in when you are going to factorize, you have to choose a common factor. You always choose the largest number. So I'm going to take 4x, which is going to be 2x plus 3. And then again for this 32 and 48. 32 divided by 2. I can take 16 common maybe. 16 divided by 2. 48 by 16. Yeah, I can take 16 common for the 32x and 48. It will be negative 16. And eventually it will be again 2x plus 3. So from this point onwards, lastly, I will just write this as 2x plus 5 and x minus 8 in the roots format, right? This is your roots format with the factorization. And then again, x minus 4, x minus 8 in the denominator. Moving on to the second fraction. On the second fraction, you have 2x plus 4. Obviously, you can write this as x plus 4 whole square, but I'm trying to keep this math in much detail as I can. So this is going to be 6x plus 15 and x minus 3 multiplied with 10x minus 15 and x minus 3, 4x minus 16 and 2x plus 3. I can clearly understand that these fractions, right? These one, this one, and this one. they can actually be broken down, like they can be made much more simpler. For example, from 6x plus 15, I can take what? 3 common. I'll just start the rough working over here that I have 6x plus 15, right? So I can take 3 common. Then I'm going to get 2x plus what? 5. So I'm going to get 2x plus 5 from there. So instead of writing this, I will actually write your 3 2x plus 5. Instead of writing 3x plus 15, I can write 3 2x plus 5. And then again, after that, we have 4x minus 16. This is going to be what? If I take 4 common, it's going to be x minus 4. So from this part again, I will not write this one. I will write 4x minus 4. And lastly, I have this 10x minus 15. In this part, I can take what? 5 common, right? The largest common factor is 5. So 2x minus 3. This one turns out to be 2x minus 3. So again, over here, I can write 2x minus 3 multiplied with 5. Is there any problem till now? Any questions so far?
No, miss.
Before we move on, let me rephrase whatever I did last time. If I'm going to zoom out a little bit, previously in the question, first fraction, second fraction were multiplied with each other, third fraction was divided, right? We use this format that whenever two fractions are in divided format, the denominator gets inverted. As you can see in this case, the denominator gets inverted and get multiplied with the numerator. The similar concept we used over here. In this part, F3, fraction 3 was in a division format. It will get inverted and get multiplied with the rest of the two fractions. That's why you can see the denominator is written on the numerator and the numerator is written on the denominator. So this is a final format. Now you have arranged the equations. Now we'll start like factorizing them because you have quadratic equations on both the numerators and denominator for the three fractions. So we did splitting over here and then we did the factorization and now we're going to cancel out similar things that are common in all the fractions. We can cancel each other, but we can cancel those. I'll just remove this. This was a rough word. For example, over here, you can understand x minus 4, x minus 8 will be cancelled out. X plus 4, x plus 4 will be cancelled out. Then 2x plus 5, 2x plus 5 will be cancelled out. X minus 3, x minus 3 will be cancelled out. Other than that, we don't have anything else that we can cancel right this time. So lastly, we can write, what do we have? X plus 4, 2x minus 3 multiplied with 5. We have these three fractions on the numerator multiplied with 5, 2x minus 3. And this is divided with what? We have a 3 in front and 3 multiplied with 4, x minus 4, and then 2x plus 3. If you move back to your question, they were asking you to keep this entire three fractions as one single fraction, right? This is in a one single fraction, but this is not in a simplified way. You would have to more simplify it. So for that simplification process, I need more space. 1 minute. So in the numerator, what happens? 5 gets multiplied with 2x minus 3, so eventually it will be 10x minus 15 again. So you have x plus 4, 10x minus 15, and then again divided by 3 multiplied with 4 is 12. 12 into x is going to be 12x, and 12 with 4 is, I think, 48, right? So 12 with 4 is 48. So 48 multiplied with 2x plus 3. Lastly, you have to multiply x plus 4 with 10x minus 15. It's going to be what? I'll just do the rough working over here. X plus 4 and 10x minus 15. So this is going to be 10x squared minus 150x plus 40x minus 4 into 15 is 60. So eventually we're going to get 10x squared, 140, and will be 110, negative 110x minus 60. So in the numerator, you're supposed to get x squared, so 10x squared, minus 110x minus 60. Okay, this is what you get in the numerator. And then similar calculation has to be done for your denominator also, where you have 12 minus 48 and 2x plus 3. So you're going to get 12 into 2 is 24x squared, 12 into 3 is 36, plus 36x, 48 into 2 is 84, and 48 into 3 is 144, minus 144. Is going to be 24x squared. 36 minus 84 is minus 48, minus 144. From the denominator now, you can write 24x squared, 48x minus 144. Now, I think from the numerator, I can take 10 common, and from the denominator, I can take 24 common. Right? So, from that case, if I'm going to take 10 common, it's going to be x squared, 11, sorry, 11x minus 6, and then again on the denominator, if I take 24 common, let me just see, 144 is divided by 24 or not. Yeah, it is. Again, we're going to get x squared and 48 by 24 is what? 2, I think. Right? Plus minus 2x minus 6. Right? At the end, 10 over 24 comes out to be 5 over 12. So finally, you get 5 x squared 11x minus 6 and 12x squared 2x minus 6. This is the final answer. If there is any question, please ask. We can solve it right now.
Tisha, I think for the equation in the numerator, it should be minus 25x, not minus 100.
Okay,
Yeah.
1 minute. What was the format? X plus 4 and 1 minute. 10x minus 15, right? You have 10x squared, 15x, 4, 15 is 60. How is 1 minute? No, how can x? Oh wait, yeah, right. X multiplied with 15 is 15 x, and then again you're going to get plus 40x minus 48. Right. So minus 60. That is 10x squared minus 15 plus 40 is 25. Right, positive 25 it should be. Okay, in that case, oh wait, then I think we have to take different comments. 1 minute. It was actually 25, positive 25x minus 60. I can take what? 5 common now easily. Right, 5 goes for 10, 25, and 60 for all the three numbers. So it will be 5 and 2x squared plus 5x and 60 over 5 is 12. Right. And then after this, I cannot simplify it anymore because in the denominator, now you have 24 and 24 and 5 cannot be cancelled with each other. So this one turns out to be your final answer. And no need to write this on your working. That was just the rough. I know, quite lengthy, right? And this kind of questions would appear in your exam also. At least one question they will ask you from simple algebra, where you have to work out with the fractions. Is there any questions for question 2? This one. For Nasser another? Yes, Akifa, please ask.
Miss, it's all
Nothing.
right.
Clear.
Okay. Ami, do you have any question?
No, miss, it's okay.
Okay, then we are going to move on. For Sharon, is there any problem, by the way, from your side? Sharon, are you in class? Okay. And for Nasser and Dushan, if you have any problem, please ask. Okay.
Yes.
Thank you. Now we're going to move to question 4, and after that, question 3 is going to be a little classwork. Question 3 is easy. You can understand that, right? You just have to what? Factorize the 4 quadratic equations and then cancel out whatever you can. Let's start with question 4. I think this is lengthy, so we should do that in class. Okay, now in question 4, they have again provided you with what? Two fractions, right? And the two fractions are divided with each other. That means what will happen? This will be getting inverted. The second one always gets inverted and then gets multiplied with the first fraction, right? This is your F1 and this is your F2. F2 will get inverted and then gets multiplied with the F1 fraction. You have to show this one for part A and then differentiate it. This is actually not part of the question. Okay, this is not part of the question. Now we are going to solve with part A. For part A, if I do not copy the question, if I start solving it from the very start, you have 2x squared minus 3x minus 2, right? I obviously understand I have to split that. So I'll start splitting it. You have 2x squared, 4x minus x minus 2. Wait, if I have 4x, this has to be positive. And then 6, from 6 and 8, I can take 2 common, right? I can take 2 common. So I'm going to get 3x minus 4. And then again, this will be multiplied with the quadratic equation. Will now move on to the numerator. So we're going to have 3x squared. As you have 24, 24 means 15 and 1. No, not that. 12 and 2 is negative 4 and 12. 1 minute. That's 4 and 6, then 16. Sorry, 18 minus 4. 18 minus 4 also gives you 14, right? So we're going to get 3x squared, 18x, 4x, 24. It was a positivity, positive 14, so 18 would become positive. And in the numerator, previously you had x minus 8, which will now be shifted to the denominator. So it gets x minus 2 over here. After this again, if I take common factors, this was a square over here. So it will be 2x, x minus 2 plus 1, x minus 2 divided by 3x minus 4 multiplied with 3x, x minus 6, so plus 6 minus 4x plus 6 divided by x minus 2. Now you have 2x plus 1, x minus 2 divided by 2, 3x minus 4 and multiplied with your 3x minus 4 x plus 6 divided by x minus 2. Now this obviously x minus 2 gets cancelled out. 3 and 3x plus 4 gets cancelled out. At the end, you're going to be left out with 2x plus 1 and x plus 6 divided by your just 2, right? In the denominator, now you have just 2. Nothing else is there. And obviously in the numerator, you have to simplify that. So it will be what? 2x squared, right? 2x squared, 6x plus, sorry, 2x squared, 12x plus x is going to be 13x plus 6 divided by 2. I think this is the format they were asking you, right? Yeah, this 12x, 2x squared, 13x plus 6 divided by 2. For shown type of maths, where for the maths you have to prove the final answer, always write a star mark for that. Okay? That you have completely proved that entire question and this is your final answer. Is there any question from part A, 2, 3, 4A?
No, miss.
Then we will quickly move to B. In part B now, they're asking about differentiation of fx and find f prime 4, if you can see. This time we have to differentiate that, and after differentiation, you have to include the value for 4 into wherever x is present in that differentiated equation. Even though we know what differentiation is, but still, for just a small recap, if you have x power n, in the differentiation process, it will be n multiplied with x n minus 1. Okay, in differentiation, the power comes in the front and then again gets subtracted with 1. So n x n by power to the power of n minus 1. This is the format for your differentiation. And for differentiation, always we cannot do differentiation. I mean, we can actually do differentiation by fraction using our partial fraction, but we're not going to use that because that is the concept of chapter 7 for this P3. Okay. We're just going to simplify the equation and write it that 2x squared divided by 2, then 13x divided by 2, then 6 by 2, which eventually makes your equation look like x squared 13 by 2x and 6 by 2 is what? 3. Okay, now I can easily factorize it, differentiate it, which is going to be 2x plus 13 by 2. And they have already provided with a value for x that is supposed to be 4. So f prime 4 is going to be 2, 4 plus 13 over 2. Can anyone calculate the value for this f prime 4 for me?
29 over 2.
29 over 2. That is your value for this part B then. Is there any question from this part B?
No, miss.
Quite easy there, right? This type of questions are quite easy. So we are done with our 1A. Chapter 1 is entirely complete. Uh, but there's a little password. Now you guys are supposed to do question 3 for me and send me a working in WhatsApp. Start doing question 3 then. Let me explain this to you again. You do not have to invert any fraction because you can see this is the fraction 1 and this is fraction 2. Right? Both the fractions are multiplied with each other. You just have to factorize this polynomial and this polynomial. And you can take common from this one. Like x can be common, which will be x minus 3. And then again over here, you can take 2x common, it will be x plus 5. Right? And at the end, you have to cancel out some things and simplify the final fraction. Start doing question 3. Question 3 is a password. I'm going to wait for like 5 minutes for you guys to complete question 3. Now, obviously, send me a working in WhatsApp. Okay. I hope all of you have access to your phones right now. You're getting x square minus 4. That is not the final answer. You can simplify it furthermore, I think. You can simplify it. For Abir, the answer is not correct. Akifa said it to be working. For Akifa, the working is correct. I'm going to wait a few more minutes for others to continue, and after that, I'll start solving that where people got wrong. Okay. For Nasser, are you facing any problem? For Nasser, Amir, Sharon, is there any problem that you guys are facing? Okay, I hope that you guys are doing this. So that's making us turn on your mic and speak. Abir, send me another word. Hmm. That should be x minus 4 on this, right? Or you can also write in the previous formula, like 2x plus 5 in the denominator. That is also right, okay, for Abir. Hmm. Yes, Sharon, your answer is correct. Over here, I actually made a mistake. Actually, this one's supposed to be negative. So you guys complete that, and then I'll come back to this question again. Actually, this was like an extremely lengthy question, and doing this on screen was tough for me, so I made a mistake with the third fraction denominator equation. I just corrected. For Amir and Nasser, are you guys done solving the maths?
Minus without sending.
Sorry, Amir, I could not listen to you. Hear you clearly. Can you repeat?
Yeah, I'm sending you.
Okay, and for Nasrin, are you there?
Yes.
Yes. Did you complete that question for you?
I'm still doing.
We'll wait for further few more minutes for Nasser to complete, and Amir send me your working. I'll check that. Before that, I can actually really like erase it over here. For example, this is supposed to be positive. In that case, this 2x minus 3, 2x minus 3 actually becomes negative. And this one then becomes positive. If that is positive, this is positive, and this part is negative. In that case, finally, this one will also be cancelled out with each other. At the end, you are going to be left out with very simple fractions. All of these things will not be there. You're only going to be left out with what? As you can see, 5 in the numerator and 4 and 3 in the denominators. So you're going to get with 5, 3, 4. That's going to be 5, 12. And that is going to be your final answer. I made a mistake in that plus minus distribution for that that fractions denominator polynomial, and because of this, these two didn't get cancelled out. And because of that, the entire fraction was extremely lengthy. But other than that, the answer would be just 5 over 12, with no more polynomials involved with the last part of your answer. Okay, so yeah, this is it. We're waiting for Amir and Master to send their problems. I actually want to open Amir's working and do this. 1 minute. I will turn off my screen. And this is actually a common mistake of for example, over here in the numerator you have x squared 2x 24 that you broke down in with 2x and 4, right? Okay, and then you have x squared x minus 3, 2x plus 5, and then again x squared 3x minus 18. And that you broke down again using 3, 6x, 3x and 18, okay? So in the numerator you got x plus 6 minus 4x plus 6, so x minus 3 and x plus 6. This one's obviously gets, wait 1 minute. X minus 3 gets cancelled out, x plus 3 gets cancelled out. What you actually get over here is that final stage you have x minus 4, and then 2x, x minus, say, plus 5, right? That means you can easily cancel out these two x's together. There's no point of multiplying there, right? The things you can automatically cancel them out. So at the end, you're going to have x minus 4 in the numerator and 2x plus 5 in the denominator. Is this clear? Any questions from this exercise 3?
Yes, miss.
Yeah, then I'll just write the answer over here, okay, because I do not have much space. X minus 4 divided by 2x plus 5. That will be your answer. Okay, then we are going to move on to 1b now. So for 1b, again, similar concepts, I think. We just have to convert these into simple fractions. I mean, for question 1 and 2, we can clearly understand they're like extremely easy. So I'm not going to do any maths from question 1 and 2. I know that's fine. We're going to start with question 3 and 4. Yeah, 1 and 2 are quite easy. Let's not waste our time on 1 and 2. Okay, for 1 and 2, you just have to do LCM over here. For 3 and 4, they are tricky maths. So we're going to do 3 and 4. For example, I'll do this one. I'll do this maths from this section. So let's start with 3E first. Previously, it was easier for me because the two fractions were either multiplied or divided. I would not have to do any LCMs over there. But for these sections, now I have to do LCM. This is question 3, question 3E. For question 3E over here, I can understand that for me in the denominator you have quadratic equations. So at the end, obviously I would have to like factorize them. So before doing the LCM, I would like to factorize them first. So for that factorization, we're going to have x squared. You have 3, so it's 2 in that case, right? So I can take x plus 2x plus 2 over 3 and then minus 4x. So I can take x squared plus 2x plus 2x plus 4 and then 1. So eventually you're going to get x plus 1 and plus 2x plus 1 over 3 and then again 1 divided by x plus 2 and then if you take 2 common, this is going to be x plus 2, right? Which is going to be x plus 2 and x plus 1, 3 and then again 1, x plus 2 and x plus 2. Or I can take x plus 2 whole square over here, right? X plus 2 whole square. Now, in order to do LCM, let's do the LCM over here. I have x plus 2, x plus 1, and then the other term was x plus 2 whole square after the LCM. From this part, I can understand I can take 1 x plus 2 as a common factor, right? So x plus 2. That will make what? X plus 1 from this portion, and then again a 1x plus 2 from the second part. At the end, I get x plus, when the LCM over here turns out to be x plus 2 whole square and then x plus 1. X plus 2 whole square is just going to be x square 4x plus 4 multiplied with x plus 1. I'll just not write, like break down them, but I'm just saying that this is how the entire expression would look like. At the end, if I want to do like LCM over here, the final factor LCM was x plus 2 whole square and x plus 1. In LCM, what do we do? Right, in LCM, this is your final LCM, right? X plus 1, 2 whole square, x plus 1, and the denominators were this one. So I'm going to like divide over here the LCM, x plus 2 whole square, x plus 1. I'm going to divide the LCM with the denominator, x plus 2, x plus 1. These leaves me out with x plus 2, like 1 x plus 2, right? So it is going to be multiplied with 3. So 3 multiplied with x plus 2. And then again, I have to divide the LCM with this denominator. So x plus 2 whole square, x plus 1 divided by x plus 2 whole square. I'm going to get 1x plus 1, right? Because this one simply cancels each other out. Because now I have minus 1 x plus 1. By the way, this is the entire rough working. Sorry, this is the entire rough working. Okay. Now from this part again, I can get what? 3x plus 6 minus x minus 1 divided by x plus 1 whole square, x plus 1, and 3x minus x is what? 2x. So you're going to get 2x plus 5 divided by x plus 1 whole square, x plus 2 whole square, x plus 1. Right? I think this is your final answer. This is your final answer. I cannot simplify it in any other way because nothing is common in between the numerator and denominator, right? That is it, the final answer. Is there any question from Question 3E. For Hamza, Sharon, and Nasser, any questions?
No, miss.
Okay, then we are going to move on to the next question. Yes, Nasser, any questions? You raised your hand.
About this LCM. So basically, how do you get x plus two, and then you squared it, and then you put x plus one, and then you wrote it as x plus one.
You're
Shouldn't it?
asking that how did I got this?
No, that LCM x plus two squared. Yeah,
Mhm.
yeah, no, yeah.
Okay, Nasser, listen to me. Now over here, the two fractions, the denominators, I have to find out the LCM of the denominators. In LCM, what do I actually intend to do is that I want to make them, combine them, and I can only combine them if they have similar denominators. Okay, so whenever two fractions are in added or subtracted in a relation, like if the two fractions are added together or subtracted from each other, only in that cases we're going to do LCM. Now over here we cannot combine them because they have different denominators, right? So over here in the LCM sections, what I did, this was your first denominator, this is your second denominator. I always try to find out the common factors, right? I can see this entire thing can be divided with x plus 1, and this one can also be divided with x plus, so x plus 2 and x plus 2. Right? Both of them have 1 x plus 2 common, right? This x plus 2 whole square indicates what? They have x plus 2, like 2x plus 2 over there, multiplied together. Let me do this LCM again over here with a little bit more detail. 1 minute. The first one was x plus 2 and x plus 1, right? And the second one that I wrote as x plus 2 whole square can also be written as x plus 2 and x plus 2. So I'm going to write this as x plus 2, x plus 2. So from this part, now I can understand they have at least one x plus 2 common for the both denominators, right? You have this 1x plus 2 and then 1x plus 2. So over here, from the common factor, I'm going to take x plus 2 common. And what does actually this indicates about the common factor? This means that I'm going to divide the denominator separately with that x plus 2. So how much would be left out at the very end? So for the graph work now, this is how you can get the what would be the answers over here in this section. X plus 2, x plus 1 divided by the common factor, x plus 2. So you get x plus 1. Right? So that's how in this part we get x plus 1. Okay? And then again, I'm going to do the same procedure for the second denominator. With the second denominator, I'm going to divide the second denominator with the first factor, x plus the common factor. And I can understand this will cancel out 1x plus 2 from the numerator, but we'll still be left out with another x plus 2. So x plus 2. And in LCM, what happens? We're going to multiply everything on the left, like outer sections of these lines, right? We have to multiply all these three together. So at the end, if I want to find out LCM now, this is going to be x plus 2, x plus 1, and x plus 2. Over here, as you have 2x plus 2, when you're going to multiply same number together, like 2 into 2 can be written as 2 squared, 5 into 5 can be written as 5 squared, right? Similarly, as you have 2x plus 2 multiplied with each other, instead of writing it like in this format, we can write it as x plus 2 whole square with x plus 1. This is a final LCM. Nasser, is this clear?
Yes, teacher.
Is there any problem from any section of this maths? Sharon, again, you're not speaking. Any problem from your side?
No, teacher.
Thank you for responding. Then we'll move on to this is 3, question 3F. Okay, we're going to solve another question from this part. This is question 3. Now again we have what? Quadratic equations in the denominator. I actually won't have enough space to solve it. Sorry. Okay. Now over here, I will do the same procedure. Before I start with the LCM, I will first factorize the denominators. Okay. So for the denominator factorization, I'm going to get what? X squared, 4x, 3x, minus 12 with x plus 2. And then again, I'll just write these things inside a bracket. Okay. And then again, in the second fraction in the denominator, we can have x squared, 2x, 3x, plus 6, and x plus 1. Okay. After this, we're going to get x plus 2. And if I take x minus 4, plus 3, x minus 4, x plus 2, plus 3, x plus 2, and then x plus 1. So you have x plus 2, x plus 3, x minus 4, and then x plus 1, x plus 3, and x plus 2. Before we start with the LCM, we can see that for both the fractions over here, we have x plus 3 common, right? I highlight this. X plus 3 is a common factor. So that will be needed for our LCM working. So for that LCM, we have x plus 3, x minus 4, x plus 3, x plus 2. I'll actually do the LCM over here, okay, so that we have enough space to explain every portion of it. Now, we have x plus 3, x minus 4. This was your first denominator. So I'm not wrong, plus 3 minus 4, right? And sorry, for your second denominator, it was x plus 3 and x plus 4. So from this part, as I can already see, both of them have this 1 x plus 3 common. So I'm going to take that as a common factor, x plus 3. And what does this common factor indicate? I have to now divide the denominator separately with x plus 3. So this is how it will look, x plus 3, x minus 4 divided by x plus 3. This turns out to be x plus 3 getting cancelled out, and finally you're going to get x minus 4. So we're going to get x minus 4 over here. And then again, we have x plus 3 and x plus 4, so x plus 2 for the second denominator. And we're going to divide that with again the common factor x plus 3. So x plus 3 gets cancelled out. We are left out with x plus 2. So x plus 2 at the end. Now you're going to have to multiply these two together for the LCM. So for that part, LCM, we are now going to get x plus 3, x minus 4, and x plus 2, which is going to be what? I'm not going to multiply this. Okay, I'll just keep it like this and then use in my equation. So we have x plus 3 plus 2 minus 4. So I'll just carry this. So before that, is there any problem from this section?
No, miss.
Okay, then we will move on. Now, instead of writing the two fractions separately, I'm going to write the total denominator as x plus 2, x plus 3, and x minus 4. And what would happen? Now over here, this is your LCM, right? So always the procedure is what? LCM divided by the denominator, whatever you get, that will be multiplied with the numerator, right? Let me repeat again. LCM divided by the denominator, and whatever you can be left with, you're going to get as a remainder. That remainder will be multiplied with the numerator. So over here, if I'm going to do the rough work, LCM was x plus 2, x plus 3, x minus 4. This will be divided by x plus 3 and x minus 4. I can clearly understand x plus 3 minus 4 plus 3 minus 4 will be cancelled out, and you're going to left out with x plus 2 only. That means for the first fractions, only x plus 2 will be multiplied with the numerator. In the numerator, you already had x plus 2. So again, we're going to multiply x plus 2 with this. In the next line, I can write x plus 2 whole square for it, right? And after that again, if I simplify it again a little bit, this was the numerator, and now I'm going to divide the numerator LCM with the second denominator, which is x plus 3 and x plus 2. This x plus 2, 3, 2, 3 gets cancelled out. You are finally left out with just x plus 4. So minus x plus 1 and x plus 4, which is going to be. Now from this part, yes, Avir, any question?
It's x minus 4, right?
Minus 4, right? Yeah, sorry. This was minus 4. Okay, now after this, I again have to simplify it. Otherwise, I don't have any option. For example, over here, this is going to be what? X plus 2 whole square, which is eventually, I'm going to apply that a plus b whole square formula. It's going to be x square plus 4x plus 4. And this has to be subtracted with what? X square minus 4x plus minus 4x plus x is going to be minus 3x minus 4. And in the denominator now, you have this polynomial. I'm not going to break down the denominator. Okay, I'll just keep it like this, that x plus 2, x plus 3, and x minus 4. From the numerator, if you simplify, we're going to get x squared 4x plus 4. So you have a bracket in front of the second, so you have a minus in front of the second bracket, in front of the second polynomial. So obviously that minus will be multiplied with the second polynomial entirely. So you're going to get minus x squared plus 3x plus 4. If I'm not wrong, wait 1 minute. Yeah, minus x squared plus 3x plus 4. So you can clearly understand x squared. Sorry, my tab is updated. Okay, minus x squared, when x squared gets cancelled out, and the denominator, you still have the same x plus 2, x plus 3, and x minus 4. One thing you can change, 3 plus 4 is going to be 7x in the numerator, and 4 plus 4 is going to be 8. X plus 2, x plus 3, and x minus 4. I cannot take anything common from the numerator because we have 7 and 8. 7 is a prime number, so nothing goes in that with that, right? So this is your final answer. And this is how you can simplify and write your final answer as. You guys can see this entire question and let me know if you have any problem. Any questions from any one of you? So I hope there is no question. We'll quickly move on to the next question. Now, I think we cannot solve 3E today. So 3B. Yeah, 3B actually has a lot of other questions. This part is also 3B. So I think we should move on to this part, the GF over here. This one is tricky. Let's not waste our time in solving question 4. That was not that much tricky. Let's move on and solve question 7 over here. Okay, question 7, they have provided you with 2 fractions and one whole number or one x, right? So you have to simplify that and then show this in this format and other cases. Always remember that if you don't have a fraction, if you have a whole number, for example, x, that actually indicates that x is actually divided over an invisible one. So what I'm going to do is that I'll first write this equation as, this is part A. I'll write this equation as x divided by 1 plus you have 6 x plus 2 and then again plus 36. You have x squared, 2x and 8, right? So I can easily use what? 4 and 2. Yeah, I can use 4 and 2. So this is going to be x squared, 2x, 4x, 8. It was minus 2, so this is supposed to be positive. Now in the next line, I can again write x divided by 1, 6, x plus 2. And then again over here, I'm going to get x plus 2 minus 4, x plus 2 with 6. Finally, in the denominator sections, you have 1, x plus 2, and then x minus 4, x plus 2. That is 6 and 6 and x. After this again, now I have to do the LCM procedure, right? I have 1, x plus 2, x plus 4, and x plus 2. From this part, I'll do the LCM over here and then I'll move it to a different space. So I have 1, x plus 2, and then x minus 4, x plus 2. I can clearly understand I can take, I actually cannot take this time x minus, the x plus 2 as a common factor because 1 does not have x plus 2 as a common factor, right? So I actually have to take 1 as a common factor, so everything will just get down. X plus 2 and then x minus 4, x plus 2. At the end of the day, if you're going to find out the LCM, 1 multiplied with 1 multiplied with x plus 2 multiplied with x minus 4, x plus 2. Eventually, 1 multiplied with 1 doesn't change anything, right? At the end, you're going to get x plus 2 whole square, x minus 4. That is your LCM process, entire LCM for this case. That means the final denominator turns out to be x plus 2 whole square, x minus 4. I'm going to take this and write it, let me make it small and keep it over here. This is your rough. Okay. Now again, what I do is that main procedure I do is that I divide the denominator with your LCM. For the first fraction, the denominator was 1, so it is going to be x plus 1, x plus 2, sorry, 2 whole square, and then x minus 4 divided by 1. So it will just remain as it is, right? X plus 2 whole square and x minus 4. So I'm going to write x multiplied with x plus 2 whole square and x plus minus 4. And this is what I'm going to get for the first fraction. And then again for the second fraction, I'm going to divide. I'll just use this one. Okay. I'm going to divide this LCM with x plus 2. So x plus 2. Obviously, this cancels each other out, and you're going to left out with 1 x plus 2 with the numerator. We have x plus 2 multiplied with x minus 4 is going to be plus 6 x plus 2 x minus 4. And then again, what I'm going to divide this entire thing with your third fraction's denominator, which was x plus 2 and x minus 4. So x plus 2 and x minus 4. This cancels out, but you're still left out with x plus 2. Like 1 x plus 2 still be left over. Because in the numerator, you had x plus 2 whole square. So at the end, you're going to get plus 36 multiplied with x plus 2. So just cancel each other out, erase this. And now I'll start with the simplification again. So you have, do I need to simplify it? Yeah, I do need to simplify it. Okay. As I was saying, this is going to be what? X square minus 4x. And then x square minus 4x. And then it is supposed to be x square plus 4x plus 4. And then you have x plus 2 and x minus 4, right? This will be x square minus 8x plus, sorry, x square minus 4x plus 2x. That's going to be minus 2x minus 8. So x square minus 2x minus 8. This was multiplied with 6. And then again we have 36x plus 72 divided by x plus 2 whole square and then x minus 4. I think I was supposed to write this in, yeah, I have to simplify it further. Okay, in that case, do I have x power 4? Right? It's x squared, then x power 4. Wait 1 minute, please. No, I'm sorry. Actually, there's a mistake. 1 minute. Because in this part, the term comes out to be x power 4. Yes, Avi. I think you figured out, right? I was supposed to take x plus 2 as a common factor over here in the LCM. Because over here, in your same part, I can clearly understand the maximum power should be x power 3, not x power 4. And I'm getting x power 4 from this equation. But multiplying x power 2 with x power 2 will give you x power 4. Now that is not correct, right? So in that case, I have to do a little bit change over here. If I zoom out from this section, I can actually take that x plus 2 as a common factor. Okay, x plus 2. And now I'm going to get what? 1 will remain as 1. This will also remain as 1. And then x plus 2 divided by x plus 2 gives you 1, right? And x minus 4, x plus 2 divided by x plus 2 will just give you x minus 4. So from this case, you're not supposed to have this x plus 2 with this part. And finally, this will be your LCM. Okay, so if that is your LCM, in that case, you're going to get a square over here, which means over here it will not have any square. In this part, it would just have your x minus 4, not that x plus 2. And then lastly, this is supposed to be your x plus 3. But this part only that x36 will be there because you have this, what? In the denominator, you already have x plus 2, x minus 4, right? And that was your LCM. It will not change for this 36 fraction. Nothing will be multiplied with the numerator of 36 and only x minus 4 will be multiplied. Why? Because when you're going to divide this with x plus 2, x plus 2 gets cancelled out and you left up with what? X plus 4 only. So only 6 multiplied with x plus 4. Now the overall calculation is quite easy. So for example, in the numerator, now you have what? X square, 8x minus, x square minus 4x plus 2x minus 8. Right, so you have x square minus 4 plus 2 will eventually give you minus 2x minus 8, then 6x minus 24 plus 36 divided by x plus 2 and x minus 4. After this, again, if you multiply that entire polynomial with x, this one, this will give you x square minus 2x, sorry, this will give you x cubed minus 2x minus 8x plus 6x. I do not have enough space, 1 minute. Minus 24 plus 36. If you do that, I think you're supposed to get like 12. Yeah, you're going to get 12. And x plus 2, x minus 4 in the denominator. At the end, you're going to get what? X cubed, x to the power of 3, you have 8 and 8 and 6, right? That will also give you minus 2. So minus 2 x power square minus 2x plus 12 divided by x plus 2 and x minus 4. That is a final fraction. I think this is what your answer was supposed to be kept in. Yeah, minus 2x square minus 2x plus 12, right? This is your final answer. As this was supposed to be a shown math, so obviously you have to write that star at the end of the answer. Is there any question from this part A?
Miss,
Yes.
can you explain me why did you take the common factor x plus 2 instead of 1?
Okay, now in LCM, for example, over here you have three numbers, right? I'm going to work with very easy numbers first. Now I'm going to work with 3, 12, and 3, 12, and 7. In this part, if I want to find out the LCM of these three numbers, I can take the common factor that is available for the two numbers only. Okay, for example, I can take what? 3 as a common factor because I can divide 3 with 3 and 12. Okay, I mean, for LCM, in order to find out the common factor, we have to use one number that is at least divisible by two of the numbers that are given in the LCM. Right. Over here, I cannot choose 7 because 7 is only divisible by this one and not by this two. So if among three numbers, there's one number that can be used to divide two numbers for the LCM, then I can use that. Okay, for this part, I can easily take 3 is going to be 1, 4, and the number which cannot be divided, it will just remain as 7. Okay, I would not write that as 7 over 3. Is this clear?
Yes, miss.
But then again, if it was the opposite way around, maybe you have like what? 7, 5, and 2. Like in this situation, you can understand that nothing goes in common over here, right? Nothing is common in this part. Yeah, nothing is common in this part. What will I do in that case? In that case, I would not do the LCM. I would just have to multiply them together. 7 into 5 into 2, that will give you the value. Right. So in my LCM case, I will choose a common factor that could be used to divide all the three numbers, or I will choose a common factor that could be that could be used to at least divide two of the three numbers. Is this clear?
Yes, miss.
Now over here we had x plus 2, so we could use that to divide two of the three numbers. So that's why I took x plus 2. Is there any questions from this part? This was just the working for part 7a, by the way. We are still yet to do 7b. But any questions from 7a?
No, miss.
Okay, then let's move on to 7b. Use algebraic long division or hence otherwise further you like find out the other factors, like solve this one. Okay. We can, if this is x squared minus 4x plus 6 divided by x minus 4. Okay. Now let me see if I do middle term over here. 1 minute. Well, I cannot actually apply middle term because the question says that I have to use long division. That means I have to use long division. 1 minute. Over here, you actually cannot factorize the numerator. That's why we're using long division. I cannot manually factorize the numerator. So what I would have to do in long division, this is the process: x squared minus 4x plus 6 and then x minus 4. In this part now, in long division, what we do is that we always divide the first number of this divisor with the first number of this dividend. And then we divide x squared over x. So this is the rough work for long division, and obviously rough work for long division are not needed as a part of your answer, okay? But I always try to keep that so that it's just easier for you to revise. So it's just going to be x squared divided by x, which is going to be x. Now this one goes to the numerator and goes to the quotient over here. And this quotient will be again multiplied with x minus 4. So you're going to get x squared minus 4x. So over here, we're going to get x squared minus 4x. In long division, we'll obviously have to subtract. So when we subtract over here, always remember this minus sign will only be assigned with the term in the base. Okay, this will not be associated with the top numbers. So previously this was positive, and when we assign the minus by this addition of minus sign in the bottom, this the x square becomes negative, right? And obviously if this becomes negative, x square minus x square will cancel them, and this minus and minus makes this 4x positive. So minus 4x plus 4x. This will obviously be what? Cancelled out again. So you're going to get cancelled out. At the end, you're going to get the remainder as 6. So this is your remainder. At the end, I am not going to get the remainder 0. I cannot further divide x with, so I cannot further divide 6 with x. That is not possible. So over here, I can write my answer in a mixed fraction format. In a mixed fraction format, the format is always in this situation. Wait, one minute. Numerator multiplied. Yeah, this is your format. X. The remainder always goes to the middle portion. Remainder in the numerator and x minus 4 in the denominator. This is your final answer then. So you're going to write your answer in this mixed format equation. Mixed equation format. So before that, let me just go back further to show that using long division, otherwise further show that this divided by this. Yeah, this is it. Any questions from this part? Yes, Nasir, I think you have any problem.
So in the denominator's place, why have you wrote it as x minus 4? Can it be like x minus 4 over 6? Is this both the same thing?
No, they're not the same thing. Let me tell you why. This is actually in a mixed fraction format. Okay, this is your mixed fraction format. In mixed fraction format, over here, your let me just use simple numbers to explain that. How can I actually extract this kind of polynomials to mixed fraction? Yes, Abir, I'll get back to you a little bit later. Okay. Now, for example, if you have like maybe 15, and we're trying to divide 15 with 2, the closest number that I can get is 14. So I'm going to get 7, that's 14, and the remainder turns out to be 1. So what this mixed fraction actually indicates that if you simplify the mixed fraction, you're going to end up with 15 by 2. Because this is what? 15 by 2 was your original fraction, right? And in your mixed fraction, what is the format? 7, 1 over 2. Right? This is the case that I'm teaching you, that the quotient should be in the side, and this remainder should be at top, and this one should be at the bottom. Now, how will we actually, what is the overall basic of of converting this mixed fraction into improper fraction? This is, by the way, and so not improper. This is, by the way, a proper fraction. No, this is with improper fraction because the numerator is big. This is an improper fraction, and this is a mixed fraction. I can actually convert the mixed fraction into an improper fraction by doing this procedure. That is, this denominator will be multiplied with the 7. So 7 multiplied with 2 added with the remainder. And that will be divided by 2. 7 into 2 gives you 14. 14 plus 1 is 15 over 2. So see, writing this will give you to the original improper fraction. But if I'm going to write this in the reversed way, 2 divided by 7, so 2 divided by 1 multiplied with 7, that will not give you to that original equation, 25 over 2. It is going to be 1 into 7 plus 2 divided by 1. It is going to be what? 9 by 1. Are they same now? Master, can you tell me, is this two equations same? Are they both referring to your original improper equation?
Uh, are they both the same? The answer is I think they're not the same as it is.
I'm sorry, I didn't understand.
Uh, like they're not the same, right?
Right, they're not the same. I'm actually explaining you the basic, and then I'll go back to your polynomial one. But just for this example, as you can see, we started with 15 over 2, right? And then we did the division, and we wrote the division. From the division, we got quotient, remainder, and then dividend, and we wrote the entire fraction as mixed fraction, right? The format of writing this mixed fraction should be always same. Quotient on the side, remainder on the top, and this dividend at the denominator. Why is that fixed? Because if you simplify it from the mixed fraction, you'll eventually get back to the original improper fraction. That's what the main idea is. You asked that can I write, instead of writing 1 over 2, can I do 2 over 1? And I did the 2 over 1, and that does not return me back to the original improper fraction. So that's why the format is always same. Quotient at the side, remainder at the numerator, and the dividend at the denominator. After this, is there any question, Nasir? Now let's go back to your polynomial. Well, what was your polynomial? It was x squared minus 4x plus 6 divided by x minus 4, right? And according to our basics, now I know the format of writing this kind of mixed fractions is remainder on top with that whatever dividend they present is multiplied with your quotient. So maybe the spelling is wrong, but you get the idea. That is your quotient. Now this is your quotient, this is your remainder, and this is your dividend. Now from this part again, if I start with my working, I have what? X, 6, x minus 4, right? My format was what? I have to multiply x minus 4. That what format was dividend multiplied with quotient added with remainder plus remainder divided by x minus 4. So now we're going to get x squared minus 4x plus 6 divided by x minus 4. Right? As we can see, we do get back to the original equation. Is this clear now? How would you actually write this kind of polynomials which cannot be entirely go back to 0 and then write this fraction as this format? Then again, this was not actually what our question was asking. Our question was asking a different format. Okay. I only introduced this so that they understand that whenever the remainder is not 0, this is how we're going to arrange your answer, your mixed fraction in mixed format. Okay. But if we go back to the question, this is actually kind of an extra. This is not related to part B. So part B now, you can say that using algebraic long division or otherwise further show that gx can be represented as this format, like x squared minus 4x plus 6. You have to work with that gx can be represented in this format. Okay. Now, in this situation, I'll work with gx. Okay. They were asking that final answer should be in that format, not that we have to just, long divide that format. Okay. I did the long division of that format only to explain you how to write your answer in this mixed fraction. Is there any problem for anyone who did not get the format of writing this into mixed fraction?
Understood, miss.
Okay. Then now we're actually going to solve part B. Okay. For part B, they have asked you that originally the gx equation was what? X cubed minus 2x squared minus 2x squared. I forgot. 1 minute. plus 12. Okay. Plus 12 divided by your x minus 2, x plus 2, x minus 4. Okay. Now I have to write this in the format of that x square minus 4x plus 6 divided by x minus 4. Okay. Now how can I write this in this format? I mean, I can clearly understand that if I can like divide this polynomial with x minus 2, then it will be a little more easier. For example, I'll start with this, that I need to first identify that if x plus 2 is a factor for the polynomial or not. Because if I can find out that, then it will be much easier. For example, again, I can actually do this very easy calculation for you. It's not needed, but I'm just explaining this for the process. X power 3 minus 2x squared minus 2x plus 12. Okay, this was the original numerator, and this was divided with x plus 2 and x minus 4. In this situation, if I have to cancel out that x plus 2 from the denominator, what do I have to do? If I can multiply that, for example, I'm going to multiply x plus 2 and then again divide x plus 2. Why am I multiplying and dividing it? Because I do not want to change anything from my original equation. So multiplying same number and dividing it with the same number actually gives you what? 1. And multiplying 1 with anything does not actually change the base of your equation, right? So by this, I'm not changing the base of my equation, but this will also help me understand that these two will cancel each other out, and at the end, you're going to be left out with what? At the end, I'm going to be left out with x squared minus 2x minus 2x plus 12. This will be divided by x plus 2, and the entire thing is divided by x minus 4. We can clearly understand that we are halfway there, right? I just have to what? Divide this polynomial with x minus 2, and whatever the remainder quotient is, that will be placed in the numerator. Is the concept clear to all of you?
Yes,
What
miss.
am I trying to do? Okay. Yes, Nasir, please ask.
So teacher, you have wrote x plus 2 over x plus 2, right? So can we write it as x minus 4 on the top and x squared minus 4x plus 2 later? So
Yeah, right. You can also do that. But problem is, if I'm going to write this way, you're suggesting that x squared minus 2x squared minus 2x plus 12, and then divided with x minus 4, and then divide with x plus 2. Problem is, we're supposed to have x minus 4 in the denominator, right? Are we getting x minus 4 in the denominator? No, that's why, I already know that my answer should be in this format, right? The answer is given to you. We just have to show this in this format. That's why writing this will not give you answer in this format. So I think that's clear right now, right? We have to keep this x minus 4 in the denominator, and we'll just divide the polynomial with x plus 2. Is this clear now?
yes, teacher.
I'll cancel this out then. We'll move on. I'll just start doing with your long division process this time with me. So you have you have x squared, 2x. So this is square, this is cube. And then x plus 2. Now over here, I'm going to divide x power 3 over x, which is going to be what? X squared. So we're going to get x squared in the quotient. And then again, x squared multiplied with x plus 2 gives you x cubed plus 2x squared. So you have x cubed plus 2x squared. This will be minus, and obviously I'm going to get x cubed cancelled out, and this negative, this one over here is going to get negative 2x squared. So negative 2x squared ends you with negative 4x squared, and I'm going to bring out 1 2x in this part. And then again, the first term I have is 4 negative 4x squared divided by x. That gives you negative 4x. In the new quotient, now you're going to get negative 4x. Negative 4x multiplied with x plus 2 gives you negative 4x squared, negative 8x. Right, negative 8x. So 4x squared, 8x, and minus, right? This will eventually be positive, right? So minus 4 plus 4 cancel each other out. And minus 2 plus 8 gives you 6x plus 12. First term over here is now 6x divided by x is 6. So plus 6. Then again what? You are going to get 6x plus 2, which is going to be 6x plus 2. So we're going to write 6x plus 2, 12 is 12. If you're going to subtract, as we have similar numbers, subtracting them will give you 0. And the remainder was entirely 0. But for the cases when the remainder is entirely 0, previously the remainder was not 0. And in cases when the remainder is not 0, for those time I will use the mixed fraction, right? And for situations when the remainder is 0, this is how the format should be. I'll again use a very simple number for you to understand. Okay. For example, again, I'm using that concept, 15 divided by 3. We're going to write 5, and then you get 15, and then the remainder is 0. So now I can write this dividend and quotient. If you multiply the dividend and quotient, you actually get that actual number 15. So 15 can be broken down as dividend multiplied with quotient. Right, that was your format. So using that concept over here, original equation was polynomial was x cubed, 2x squared, 2x plus 12. I can now break this down as what? X plus 2 and your again what? X squared minus 4x plus 6, right? Is this clear? Whenever the remainder is 0, you can write down in this format. These are the 3 sections for your long division upward. After that, you can now go back to this equation. Okay, the original equation we started with, I'm going to start with the first equation, okay? Like that gx. But now I have already arranged the gx. The gx was in this format, that x squared minus 2x, x squared, sorry, was x cubed minus 2x squared minus 2x plus 12 divided by, this was divided by a further x plus 2 and then x plus minus 4, right? Now, since I already know I can break down this polynomial in this format, right? I can write this polynomial in this format. I'm going to write it as x plus 2, x plus 2, x square minus 4x plus 6 multiplied with, I can actually write this as in this format, but this was actually divided with this term, right? So x plus 2, and this entire fraction is divided by x minus 4. So this 2 gets cancelled out, and you're left out with x squared minus 4x plus 6, x minus 4. And this is how you completely show your voltage. I cannot actually fit all these things in one screen, but is this clear to all of you?
Yes, miss.
Or, Master, is this clear?
Yes, teacher.
Now, from this part, we understood one thing, right? That if in long division the remainder is 0, in that case, I can just multiply the dividend with the quotient to get the original polynomial. And if the remainder is not 0, then I have to use the mixed format fraction, right? Then I have to write my answer in this format. Quotient multiplied with the remainder of the dividend. This is it. I will actually stop the class over here. I took a long time for this. I'm sorry. So yeah, this is it for our trial class. I'm going to stop the class over here. I think for last year, you don't know the entire routine. This is our routine. I think you are also from Dubai or Qatar. I'm not sure. I mean, these are the timings in terms of Saudi and Qatar, but I'm not sure where are you from. Yeah, the timings should be same for. I think if you're from Dubai, then the timing will be different. But if you're from Qatar or Saudi, the timings would be same. But if you're not, then I would actually give you the timing according to your time. So just give me a message in my WhatsApp. And so this is our trial class from the next class, which is going to be on Thursday, 1 p.m. at your time. We're going to have our regular classes. So this is it. We no, not actually. Yeah, Thursday 1 p.m. Right? We're going to start our classes on this week, Thursday 1 p.m. And if you guys want to continue with the classes, just inform me in my WhatsApp. I will create a group and add you guys to that group. Okay then, thank you for joining my class. I will stop the class over here now.